question. It covers 2 different pages, and it basically asks you everything that there is to know about regression equations. We're really going to focus and spend some time on number 8 so that you can fully understand. Now, what we're going to start is the following information. I'm reading it. The following information was collected regarding IELTS score and GPA for students at DMC. We have IELTS, we have GPA. Now, we know we need to define the independent and dependent variable because it's not actually listed here. If we look at this, what actually comes first? Well, knocked it out of place. There we go. Which one comes first? Before you can get a GPA, you have to do your IELTS exam. Therefore, the IELTS is the independent variable, and the GPA is the dependent variable. So now we're going to go ahead and put this into our equation. But when we go, even though it's on stat, it's not on to variable statistics. So we're going to click mode and go into stat, and we're doing a plus bx. This is the regressional equation. So 2. And if you notice, it comes up with x, y, and frequency. Now, it's okay to leave frequency on in this case because you don't have a lot of variables, but if you do have a lot of variables, make sure to turn frequency off. So we'll put in x, 5, 5, 5.5, 5.5, 5, 6, 5, 5.5, 6.5, and 6. So 10 variables. Now we'll move over to y. 3.0, which is 3, 1.9, 2.1, 3.4, 2.7, 3.9, 3.2, 3.6, and 4.0, which is 4, followed by 3.7, which is our last number. So we have 10 numbers in our list. We're going to go back to the home screen so that we can actually do some calculations. Find the correlation coefficient and comment. Now, correlation coefficient, this is one of our vocabulary words. This is asking you for the R. So you're not doing R squared, you're just doing R. So if we set this up, there we go, we're going to do shift 1, and we're going to be doing regression in this case and finding R. And we find that R equals 0.696. But remember, we tend to round to 2 decimal places. So we're going to go ahead and round this and call it 0.70. Now, because it's 0.70, this means, and it's positive, this means it has a strong, positive, linear relationship. Okay, now we need to find the coefficient of determination and comment on that. Now, the coefficient of determination is r squared. So all we're going to do is square our answer, and we get r squared is 0.485. Rounded to 2 decimals is 0.49. In other words, 49% can be determined based on the information given. Okay, find the regression equation. Now we know that our regression equation is going to be the slope times x plus the y-intercept. So once again, we're going to go here, move this down so y'all can see the screen, shift 1, go into regression, and we're going to start by doing the slope. So the slope is 0.96. So y equals 0.96x. We'll go ahead and do A, shift 1, 5, and A, minus 2.13. Okay, so this is the equation. This is r squared. This is r. What percent of my data cannot be determined using the regression model? Okay, so we found out what percent can be determined, and in order to figure out what percent cannot be, you have to take 100% and subtract 49%. In other words, 51% cannot be determined. So we're looking at an equation that, even though it fits our data, doesn't necessarily have a really strong stuff. Okay, if Hamid earned a 6.0 IELTS, what do you predict his GPA would be? So in this case, we're going to look at this. Y equals 0.96 times 6.0 minus 2.13. Okay, so we'll go back to our home screen and put this equation in. 0.96 times 6.0 minus 2.13. And we predict that his GPA will be 3.63. Okay, what type of relationship is this model? Well, this is where we talked about this. This is a strong, positive, linear relationship. Okay, even though I will admit it is not nearly as strong as we would like it to be. If Saeed's GPA is 3.6, what do you think his IELTS score is based on the regression model? So in this case, the GPA is our Y value. So we need to actually solve this. 3.6 equals 0.96x minus 2.13. Okay, we'll move this over so that y'all can see. Now we need to start by moving the 2.13 over. So subtract 2.13, 3.6 minus 2.13. Sorry, it's plus because when you move it over it becomes positive. So plus 2.13 is 5.73. Now 5.73 equals 0.96x. Now in order to solve this, we need to divide both sides by 0.96 so we can get the x alone. So divided by 0.96 means we're looking at an IELTS score of about 5.97. The reason we put 7 is that the 8 makes the 6 round up. It says, for what would the GPA be for an IELTS score of 5.5? Okay, so this one is really easy. We just plug it in. Y equals 0.96 times 5.5 minus 2.13. So 0.96 times 5.5 minus 2.13 gives us a GPA of 3.15. Now the next one, 0.96 times 7.5 minus 2.13. So 0.96 times 7.5 minus 2.13 gives us a GPA of 5.07. And then it says, which of these is more reliable? Now if we look, 5.5 is in our data set. It's found multiple places. 7.5 is well out of our data set. This right here is our maximum number. And this is a full step above maximum. Therefore, 5.5 is more reliable. And this is how you kind of solve some stuff with regression equations.